On this channel, we provide useful programming information with practical code examples. This time, we'll cover generators in Python. We will comprehensively explain generators, including their basic concepts, generator expressions, and error handling examples. Enabling subtitles will make the code descriptions easier to understand. Python generators are a type of iterator and a powerful feature for performing repetitive processing efficiently. They enable you to write memory-efficient code when dealing with large amounts of data. A generator in Python is a special function that produces one value at a time, defined using the yield keyword. Its characteristic is that it pauses execution while retaining its state and can resume later. Yield is a keyword that returns a value and pauses the function execution at the same time. When called, this function returns a generator object that yields values one by one. If you call next when there is no next value, a stop iteration error will occur. By explicitly handling the stop iteration error like this, you can detect when a generator has finished. Calling send value resumes the generator and sends value to the position of the yield expression. The sent value can be received on the generator side as the return value of the yield expression. On the first call, you cannot send anything other than none with send value, so you must use next or send none. With send 10, the generator's yield becomes an expression that returns 10, and 10 is assigned to x. Calling throw resumes the generator and raises an exception at the position of the paused yield. You can handle the exception inside the generator to continue processing. If the exception is not caught, it propagates outward and the generator ends. In this code, throw is called to inject an exception into the generator. On the generator side, the exception is handled and recovered is returned. Calling close terminates the generator. Inside the generator, you can perform cleanup using finally. Calling next or send after calling close raises a stop iteration error. This code shows that calling close terminates the generator and triggers the cleanup process in finally. Yield from is syntax used for delegating to a subgenerator. It is a simple way to call another generator inside a generator and pass through all of its values to the outer scope. This code delegates all values from the subgenerator to the outer generator using yield from and then yields 3. Generators internally implement iter and next, making them a type of iterator. Therefore, they are fully compatible with iterable operations such as for loops. In Python, a for loop internally uses next to automatically retrieve values. With this method, handling of stop iteration is also automatic. It is possible to create infinite loops, but care must be taken when using them. Generator expressions, written using parentheses, allow you to define generators with syntax similar to list comprehensions. Unlike list comprehensions, they do not load all elements into memory at once, making them more memory efficient. Exceptions may occur inside a generator. In such cases, you use try except, just like in regular Python code. In this example, proper error handling is performed in the event of a division by 0. If an exception occurs inside the generator, it will be raised when the generator is resumed. This generator returns 1 first. The error raised upon resuming is caught and displayed as an error message. Let's look at some use cases of generators. This function reads a text file line by line using an iterator, trims whitespace from each line, and returns it as a generator, allowing large files to be processed with low memory usage. This code uses a generator to sequentially generate Fibonacci numbers less than the upper limit and outputs them using a for loop. Generators can also be used in the following scenarios. Sequential processing of large CSV or log files. API pagination. Processing streaming data, e.g., Kafka, IoT devices. By using generators, you can efficiently process large datasets while conserving memory and keeping your code concise. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. If you'd like to enjoy more content, please subscribe to the channel.